A town has 1,000 people. It grows 3% annually. So the question is, when will the town reach 1,300 people? We've already talked about how we can set up a model using a times bx. We have 1,000 people to start. We're growing at 3% annually. And then we have t here. The question is, when will it reach 1,300? They're not giving us time. They're giving us kind of a goal, and we need to figure out what time will it take to get there. So I'm setting it up like this. We put 1,300 as our answer, and we need to go backwards. And this is why we need logarithms. First step, divide both sides by 1,000. That will get rid of the thousands. We'll get 1.03 to the t power, and this will give us 1.3 when you divide it. Now this is where the logarithm comes in. We want to figure out the answer to an exponential, and so I need to log both sides. I'm going to just choose regular log of 1.3. It actually doesn't matter which one you use, but let's just keep it simple and keep it to log. Now we're going to use the power down rule by taking this power and bringing it out. Okay, now we have a simple equation where we have t here, and we need to divide by this on both sides to get t alone. So let me write it right here. If I divide by log 1.3 and 1.03, I have log of 1.3 all over log of 1.03. Now you will have to do this in your calculator. Put this in your calculator carefully, and I'm getting a time of 8.876. So approximately 9 years from now, the population should be 1,300. Now the nice thing about these problems are, if you take 9 and put it way back in the beginning, put it in your formula, you can check your work. So another example here. Atoms decaying are really popular in this particular idea. A certain iodine decays 8.66% a day continuously, and so that means that we're going to be using PERT. When would 30 grams decay to 23? So I start right away by writing PERT. I start with 30 times E. I'm decaying at 8.66 grams a day. Now I'm going to set that equal to 23 because that's kind of our goal. So what do I do on both sides? I divide by 30 first. We will have e to the negative 0.0866 t equals, and I'm just going to leave it as 23 over 30. Now, there's another way to do this. In the first problem, we logged both sides and used the power down rule. Now, the other way that you could do this, especially with e, is to translate right now. I'm going to turn this into a logarithm, which means I'm going to be doing a log base e, which is the natural log. And then remember that these switch when you're doing translating. So it'll be 23 over 30 equals negative 0.0866 t. So between here and here, I translate it. Okay, and then the last step here is I'm going to do ln of 23 over 30 and divide by negative 0.0866. Alright. When I work that out, I get an answer of 3.068. So approximately 3 days we should decay to 23 grams. And again, the really nice thing about this, if you put 23 back in the beginning, you can check your work.